Good morning, everyone. Okay, my name is Karen Schlatter. I'm the Adaptive Management Specialist / Monitoring Program Manager for the Colorado River Delta Program at the Sonoran Institute. The Sonoran Institute is a conservation nonprofit organization that's based in Tucson, Arizona. We primarily do on-the-ground restoration work in the Colorado River Delta in Mexico, but we have other work throughout the West that surrounds community collaboration and finding solutions for communities and environmental issues. I will be presenting today on restoration scenarios that were developed as part of a binational negotiation process for the next agreement between the U.S. and Mexico for the Colorado River Delta. And as you can see from my list of co-authors here, this was very much a collaborative project. A lot of different groups involved, and I'll just mention some of those groups that were part of the core scenario development team. So Predator and the West Bay, Sonoran Institute, the Nature Conservancy, Universidad de Baja California, the University of Arizona, and the Delta Water Trust, which is also known as Restauremos. And then we had some additional technical support from those folks on the bottom list there. So I'll first provide a little bit of background on the Colorado River Delta, and then I'll get into development of restoration scenarios and more around the binational policy process. So the Colorado River Delta is located in northwestern Mexico. The region in the square there is basically what was an historic delta, but as you can see here on this satellite image on the right, all of that green is an agricultural landscape. So that's mostly what it consists of today is agricultural farm fields. The Colorado River goes through it, and then the Rio Party is a tributary of the Colorado in Mexico, and there's also a few remnant wetland areas within the delta. Historically, the delta was 2 million acres of riparian and marsh and estuarine habitat. But essentially, since about the mid-1900s, with upstream dams and diversions, the Colorado River stopped flowing to the delta and stopped flowing to the sea, and that resulted in desiccation and degradation of habitat in the delta. And today, I think there's less than 10% of the original habitat remaining. So there's been extensive degradation of habitat in the delta, but despite that, there are remnant wetland areas that have extreme ecological significance. It's located in a very dry area in Mexico, and so even these remnant wetland sites have ecological importance. There's several endangered species that are supported by habitat in the delta. There's a biosphere reserve, 2 Ramsar wetland sites, so it's very important ecologically, and also, over the past 5 years especially, it has gained international significance with the dedication of environmental flows to the region for restoration. And so I'll talk a little bit about Minute 319, which was an agreement passed in 2012 by the U.S. and Mexico. It's actually in addition to the 1944 U.S.-Mexico Water Treaty. And it's a landmark agreement because it dedicates water to the river in Mexico for the first time in history. And it's actually the only agreement in the world to date that dedicates water on a binational river for environmental purposes. So really a significant achievement. It's a 5-year term, so it goes from 2013 to 2017. And in addition to providing water to restoration in the delta, there's a lot of other components involved with it, otherwise it would never have gotten passed. So it provides new guidelines for management of the Colorado River during times of drought. It promotes investments in water conservation as well. And in terms of the amount of flows provided to the delta within 319, there's a total of 195 million cubic meters. The way that was distributed was about 1/3 of those flows was dedicated as base flows. So these are low magnitude habitat maintenance flows to be dedicated to the delta over the whole term of Minute 319, so the 5-year term. And then the other 2/3 of those flows, 100 million cubic meters, 130 million cubic meters, sorry, was dedicated as a one-time pulse flow release, which occurred in the spring of 2014. How many of you are aware of that release of water? Good. So I talked last year, if you were here, about the vegetation response to that pulse flow release. In addition to the water dedication, a collaboration of NGOs is working to restore 2,300 acres of habitat during that 5-year term as well. And the hope is that we will be renegotiating this agreement at the end of the 5-year term. So if you're not aware, it's 2017, which means the agreement expires at the end of this year. So negotiations are currently ongoing. Which brings me to the next minute, which is termed Minute 32X. It's called Minute 32X because they don't know what number it will be exactly, so they put a generic X at the end. But it's essentially the next water agreement between the U.S. and Mexico. How this process goes is there's a minute negotiation group that's formed of various stakeholders throughout the basin. U.S. Mexican government agencies, tribal groups, various stakeholders, and work groups are created to help solve issues and find solutions to various components that are going on in the basin. So one of those groups is known as the Environmental Work Group. This group is made up of U.S. and Mexican government agencies, NGOs, academic institutions, and water users. And there's a few of the people in this audience are part of that group. Their task is to provide recommendations to the minute negotiating group on specifically restoration and water deliveries to the Delta for environmental purposes. So I'm only going to talk about one specific task that the environmental work group had. They had a bunch of other ones too, but today I'm just going to talk about their work to define restoration scenarios and potential benefits of those scenarios for 4 different water flow volumes. And those flow volumes were given to that group by the minute negotiation group. And the negotiations are still ongoing, so I'm unable to give those volumes to you today, but just to give you a sense, they range from low to high. The lowest is about the amount that would be needed to support habitat that has already been restored in the Delta, and then it ranges up to a high amount that was more than the pulse flow release. So looking at this task, how are we going to develop restoration scenarios for these different environmental flow volumes? Well, probably you're going to need a group of scientists to take on that task. So a sub-team of scientists was formed. Sonoran Institute and others that I mentioned previously got together, had a series of workshops, series of meetings, and then several presentations. And for each scenario, we were tasked to develop, define the hydrologic and ecological conditions of the flow releases and then the restoration activities, define that type of environmental enhancement that would occur, and then consider the political and operational limitations when defining those restoration scenarios as well. So given treaty limitations, of course, a group of scientists who wants to restore the Delta, we would shoot for the ideal scenario, but we have to work within the boundaries that we have in the Colorado River system, and specifically that international management of water. And then we were tasked to estimate benefits and impacts of those environmental flow deliveries and restoration activities. So the group of scientists got together and we started to define a process. This all occurred early last year, so February to March was when this was happening. So they started working on this task fairly early in the negotiation process. And the subgroup of scientists we first determined that we needed to set out our restoration priorities for the Delta and then transform those into water delivery priorities. So where are the key areas that we want to restore? Where are conditions currently suitable for restoration? And how can we get the most effective use of flows going forward? And we termed those items our menu items. So these menu items were kind of like packages of restoration goals that could be achieved with one sort of flow volume. And then we went on to estimate the water needs that would be needed for each of those menu items. We also tried to estimate the water balance, so looking at inflows and outflows so that we could potentially use a certain amount of water to meet multiple goals. So maybe we would meet a habitat goal upstream, and by knowing the amount of water that would flow all the way out to the middle part of the delta, for example, we could meet a recreational or a social goal in the middle part of the delta. We also considered interannual variability, which was a great, allowed for a lot more flexibility in designing the restoration scenarios. We could build in potentially more like flood flows in some years and lower flows in other years to get more ecological response. We also incorporated lessons learned from the pulse flow. This was a big part of the development of the scenarios. And then, of course, the limitations that I was previously discussing. And then we determined our methods to quantify and qualify the benefits from the scenarios. So, first of all, we needed to prioritize our water needs. We laid out a number of categories that we could, that were basically our goals for water delivery. So, firstly, we knew we needed to support existing vegetation with the water deliveries. That included restored areas and areas that would be restored by the end of minute 319, and then also areas of remnant native vegetation. We also wanted to create new restored areas, so there was both passive and active restoration potential. And then a big component was including water for recreational flows. This is where the lessons learned from minute 319 comes in. With the delivery of the pulse flow in 2014, one of the big lessons learned was the impact socially was much greater than expected, I think, by the scientific community, and kind of made aware of the scientific community that we really needed to take into consideration environmental flows for not just wildlife and habitat, but also for the communities that live along the river. So that was a big component. And then lastly, we considered trying to achieve components of connectivity and landscape scale restoration. In making this list of our prioritized water needs, we tried to make restoration scenario packages where we could overlap these needs. So, like I was saying, maybe we supported existing vegetation in the area closest to Morelos Dam, at the top of the stretch in Mexico, while we were also supporting a recreational need a little bit further downstream. So we tried to combine and meet needs as much as possible to get an efficient use of water. I'll also note that for the connectivity component, having a continuous surface flow in the Colorado River in Mexico is not an option. So what we did for this component is try to include, to the extent possible, trying to achieve connectivity along the length of sections of the river while also meeting these other goals that we had in mind. So it wasn't a huge priority just because of the unpracticality of connecting the entire length of the river. In terms of thinking about our restoration priorities, we already had conservation priorities defined. This was part of a previous initiative that we developed this map a year before. And you can see here that these areas in the green are actually sites for active restoration potential. There are some areas in the blue close to the top. This is the U.S.-Mexico border, and this is where Morelos Dam is. It's the last dam on the Colorado River. Areas up here where you're more likely to get passive restoration response. So here we had a good idea of our restoration priorities. These were developed based on existing site conditions, data that was collected over the years in the Delta. To get an estimate of water needs for these different restoration goals and social goals, we used a few different tools. For restoring and remnant vegetation, we had estimates of acreages, and then we used evapotranspiration to get an estimate of how much water those habitats would need and would be using on an annual basis. For areas of new passive restoration, again, these are fairly rough calculations done by a group of scientists in about 3 weeks, so we didn't have much time to do this. This whole process could take anywhere from 1 to 2 years if you were to really go for it. We were in a time constraint, so we did what we could. So to estimate water needs for new passive restoration, we used a HEC-RES model to predict, how much water would be needed to inundate certain areas and key target restoration sites. Similarly, for recreational purposes, we used HEC-RES surface water modeling to estimate the extent of inundation and duration. So where the water would be flowing by riverside communities. So once we had our restoration scenarios developed, we then had to determine the benefits that could be achieved with the restoration. So we took into account several different metrics, and these are all listed at the top of this table, which I'm sure you can't read very well. So I'll list them here as well. So firstly, we tried to estimate the amount of remnant riparian habitat and marsh habitat that would be supported. We estimated restored habitat that would be supported, new habitat that would be restored, the annual long-term water need to maintain that habitat. This isn't so much a benefit, but it was an important consideration for decision makers to know that longer-term water need. We also looked at river connectivity, so to what extent the river would be connected along the length. We also looked at potential for enhancement of the estuary, which is the lowermost region in the Delta. And then we also estimated the annual aquifer recharge. So this is also an important component, particularly in areas where you might be getting high infiltration of water. You're providing recharge. So those are important benefits to consider. With using this type of matrix, we were able to put all of our scenarios side by side and see how they matched up. So we were able to select the most beneficial ecological and social restoration scenarios going forward for each flow volume. Yes, the social benefits. And as you can see from these metrics that we used for each component, some of them are more specific with an actual number of hectares or acres. Others are more of a range, and that just it gives you an idea of the level of certainty that we had for each component. So to estimate social benefits, that's rather difficult to do, but we had an idea based on population centers and the amount of water that would be flowing by population centers, and trying to get a low, medium, high range, which we knew was not, quantitative estimate, but was some sort of estimate. So we also provided a level of confidence here, which is an important part to estimating these benefits, and a great way to communicate to the decision makers our level of confidence in these estimations. In quantifying the benefits, we used a number of tools to get our estimates. So for hydrological models, we used inundation extent and duration under different flow scenarios using the HEC-RES surface model. We took infiltration estimates to get recharge volumes. We also used a hydrodynamic model that was developed by Mark Stone at the University of New Mexico to look at the level of salinity reduction that could occur under different flow scenarios in the estuary. We used vegetation classification maps that were developed from LiDAR data. Jeff Milliken of the Bureau of Reclamation developed these, and this helped us get an estimation of remnant habitat sites, and then we used estimates of evapotranspiration to get rough estimates of the amount of water that habitat was using. And then, of course, we provided our level of confidence for each estimate. So I'm just going to click through a few slides here to show you some images of the tools that we used. This is an example of our transient headgrass model results. So you can see blue, green, and yellow. These are basically the extent of inundation under some different flow volumes. So using headgrass, we could determine where areas for passive restoration could potentially occur, where areas could have recreational value. These maps are also using the headgrass results, but they're putting restoration on top of that. So we have in the yellow here, it looks kind of green actually on the screen, but the yellow areas are areas of active restoration where we'd be irrigating, planting trees, and removing exotic vegetation. The areas of the blue and the green are potential passive restoration sites. This map shows an example of the canopy scale vegetation map that Jeff Milliken developed from LiDAR. So you can see there's different habitat types, and we're able to group those, get acreages for the amount of habitat, and then estimate evapotranspiration use. This graph shows reduction of salinity with a certain flow volume in the estuary. So using a starting salinity is an issue in the estuary. Basically, there's not freshwater flows to flush out salts that build up over time, and it's detrimental to wildlife. So starting with a 75 parts per thousand salinity in this area of the estuary, we saw that one flow volume could bring it down to below 30 parts per thousand, which was fairly significant. So this is just to give you an idea of some of the results and tools that we used in this process. We did make some assumptions, develop the restoration scenarios, including the use of current groundwater levels, particularly in the upper part of the delta, which is known as the limit trough. Groundwater is currently in decline, so that's an important consideration for going forward with these scenarios. We did assume seepage and evapotranspiration rates, and we assumed current channel geomorphology for some areas and modifications to enhance connectivity in other areas. We also assumed that some water delivery infrastructure needs would be met. So our results were presented to the environmental work group, who then communicated that to the minute negotiation team last spring. And in addition to presenting the restoration scenarios and benefits, we also developed a restoration and monitoring budget, which was presented along with those materials. And so I think I'm actually wearing this exact same outfit in this photo. Time to go shopping. And in summary, also I should note that so the negotiations are still ongoing. We're hoping to conclude them by the end of this year. And I'll wait till questions. I'm sure you guys will have some questions for me about that. But in summary, this is a great example of the use of modeling and data to inform binational water policy. So trying to incorporate what we've learned from experimental flow releases in the past and use that for potential flow releases in the future. In addition, we're combining multiple priorities, so meeting the needs of not only ecological goals, but also social goals going forward with these restoration scenarios. And then, of course, I think it's important with any sort of science that you're doing is to include that level of uncertainty to help communicate to decision makers that this is an ongoing process and This is our best guess at the moment. And I think that is all I have. I have acknowledgements for the actual negotiation group, the environmental work group. And with that, hopefully I have time for a few questions. So thank you.
So you mentioned that you need to classify using LiDAR data. But for LiDAR data, just measures the height and not the resolution. So how did you do? And another question regarding mentioned also like estimate for carbon transpiration. So for the trees, which reference ET did you use? Thank you very much.
So the LiDAR, the vegetation mapping, Jeff Milliken used LiDAR data and spectral imagery. I didn't include that in here too. He created an algorithm basically to classify habitat based on satellite imagery and the LiDAR when he did that. Yeah, yeah. Your second question was, remind me? Oh, yeah, I did have a slide in here, like right before this, right before I finalized the presentation, which included a list of references for the evapotranspiration estimates. There was a variety of sources that we pulled from. One that we used pretty heavily was the Lower Colorado River multi-species conservation ET estimates. I'd have to find the exact document, but there are multiple references and sources that we use, and I can send that to you if you're interested.